So, okay class, good evening. This is Rahul Ranjan Sharma from ONOCN Academy. Today we will deal a topic of class 10th that is refractive index. Okay. So, it include what this topic include. This is from light chapter, that is for the class 10th, very important chapter. So, we will read here the property of refraction. So, what are the objective? First we need to introduce it. Okay. So, first we read the concept of refraction. What we will read? The concept of refraction. Okay. Next we will read about the refractive index. Okay. We will read about the refractive index and its significance. So, this is a most important topic. Now, the definition of the refraction will be included here. Next, visual light refraction through a glass slab. We will see there how a light bend when passing from a rarer medium to denser medium, or denser medium to rarer medium, or vice versa. Okay. So, we also read about the properties of the medium there. Next is the what? The condition of the formula and their application. We will solve some numerical problems on this, and also we will read the real world application of refraction. Okay. And so, now we will read this type of things. Next, so here, okay, understanding the notation, and from here anti-counting the refractive index. Yes, we have done it. Okay. Now, so first we will read what is refraction. First we will read what is refraction. So, before this topic, we have also read about the reflection. So, the phenomena of bending of the light, okay, that shows some special properties that are reflection, refraction, dispersion. Okay. So, there will be the three main phenomena. First is what? Reflection, second is refraction, and third is dispersion. So, now we will read about the refraction of light. So, what is refraction of light? Refraction of light is defined as the when a ray of light passes from one medium to another medium. If one medium to another medium, then refraction happen. Okay. So, refraction is what? Refraction is the bending of light. Refraction is what? Bending of light as it passes from the one medium to another medium. Let us consider here, there will be the two types of the medium, that is first rarer medium, and second is the what? Denser medium. As the name appear here, denser means the medium have the more density than the other medium. Okay. So, denser medium is what? Having the more density. So, if a light, suppose that here is the two medium, this is a denser medium and this is a rare medium. If a light coming from a rarer medium and passing through denser medium, then it will bend towards the normal. It will bend what? Towards the normal. Okay. Next is what? If light goes from the denser medium to rarer medium, it will goes away from the normal. So, there be the two properties of the light which we seen in passing through the one medium to another medium, that if a ray of light pass from rarer medium means what? The medium is means what? The medium is more vacant than respect to the denser medium. Okay na? So, more vacant means there be more space. There be what? More space. In the case of what? Rarer medium. In the case of rarer medium, there will be the more vacant space. So, if a ray of light moves from denser to rarer medium, rarer medium, then the ray will deviate from the normal, means it bends away from the normal. It bends away from the normal. So, D2R means what? Away. Away from where? Normal. Next, the opposite things, R2D. R2D means what? Towards normal. Towards normal. And why it's happened? It's happened due to the density of the medium. Why it's happened? Due to the density of the medium. Next, it occurs. Why it occurs? Because the speed of light changes in various media. Let us talk about the, if there be the more population or more density, then the speed of light will got what? Decrease. It is same as the, if there be the more crowd, then the speed of the vehicle will decrease. Similarly for the light phenomena, if there will be the more denser medium, then the speed of light will what? Decrease. Okay. Next, if there will be the more rarer medium, if there be the more vacant place, then the speed of the car automatically increase. So, here it also, if there be the rarer medium, the speed of light, what? It will goes on increase. Okay. So, now it occurs why? It occurs because the speed of light will what? Change from passing from one medium to another medium. Next, light bend towards the normal. As I have also taught you, what? Light bends towards the normal when it enters a denser medium and away from the normal when in a rarer medium. Okay. So, let us see how it bend or how it make away from. Suppose that what happened? Suppose that this is a medium first. Here it is nothing but air. Air means what? More vacant space. More vacant space. Okay. Suppose that it is medium second, or let us say it is IL. IL means what? Less vacant space. Less vacant space. So, here when it is air, then it is what? Rarer medium with respect to what? With respect to IL. So, IL become what? Denser medium. Okay. When a ray of light coming from medium first, so the coming ray means this is known as what? Incident ray. So, when a ray of light coming from medium first, it enters to the medium second, it enters to the what? Medium second. So, medium second, thus the light will go what? Slower, means speed of light will decrease. If speed of light will decrease, then what will happen? It will try to move towards the normal. It will try to what? Moves towards the normal. So, this light try to move towards the normal, and this point is what? Normal, NN. The real diagram is what? If the main path of the this ray of light is NO, but it what? Due to the change of the medium, it moved towards the normal. This is clear? Now, let us suppose the same condition where this is a rarer medium and this is a denser medium. Okay. So, when a ray comes from a denser medium, so it will call incident ray comes from what? Denser medium. So, where it pass, it makes there a normal. Okay. So, this is a normal. So, when it comes from a denser medium and passes through the rare medium, the speed of light become what? The speed of light will go on increasing. Okay. So, that will increase. When it will increase, when it will increase, this means what? This means the ray of the light moves away from the normal. Moves what? Away from the normal. This is the similar phenomenon as the government buses. If the government buses have the more crowd, one will what? One will moves towards the another. Okay. Means that means what? One upon another, one upon another, one upon another. They are what? They are just sticking to another. Okay. So, here when we will enter to the denser medium, what? This incident ray trying to stick with normal. Okay. And when there be the vacant bus, when there will be the vacant bus, one will moves away from the another. Okay. That means what? That means what? Here this incident ray is moving away from the normal. That is clear? That is clear? Depending upon the what? Depending upon the speed of light, and when it goes from the rarer to denser, a speed of light will decrease, and when it goes from the denser to rarer, a speed of light will increase. That is clear? Okay. So, this is the main phenomenon of the change of the medium. Now, let us move towards the another thing, that is the laws of refraction. So, as we have know that refraction occur when there be the change of medium. Refraction occur when there be the change of medium, and how it will occur? There be the bending of the light towards the normal or away from the normal. Now, so let us see here what the incident ray and the refracted ray and the normal to the interference all lies in the same plane. This is similar to the first condition of the reflection of the light, where we have read that what? Incident ray, reflected ray and normal lies in the same plane. Similarly, here incident ray, refracted ray and the normal lies in the same plane. It is clear? Let us see what it wanted to say. If suppose that this is medium second and this is medium first. Okay. So, this is medium second, this is medium first as incident ray. So, this ray is known as what? Incident ray I. This is known as what? Normal. And if it wanted to move away from the normal, this become what? This become refracted ray. This become what? Refracted ray. And after emerging from the medium 2, suppose that it is emerging similarly from here, I am indicating here. Okay, na? So, if it is emerging from medium second, it will called what? Emergent ray. Emergent ray. Okay. So, here you can see that incident ray, this is a normal and refracted ray. All lies on the same point. Okay, the main point is here, main center is here. So, it is written here the incident ray, the refracted ray and the normal lies in the same plane. This is the first property of the refraction of light, or it is also known as the laws of refraction. Laws of refraction. Next, so let us suppose here I wanted to resolve this by a figure, but first we will read the second law. What is the second law? The ratio of the sine of the angle of incident to the sine of the angle of refraction is constant. The ratio of sine of the incident to the sine of the refraction is always constant, and this is known as Snell's law. This is known as what? Snell's law. So according to Snell's law, the angle of sine of incident ray, that we will call sin I is directly proportional to sine of refraction, that is r. So sin I is directly proportional to sin r. Now it become what? Sin I is equal to k into sin r. On removing the sign of the proportionality, we will got sin I is equal to k into sin r, or let us see, this is not a k, this become what? This become mu. Okay. So sin I is equal to what? Mu into sin r. Now mu become what? That will equal to sin I upon sin r. This is known as what? Mu is known as refractive index of a material or medium. Refractive index of a material or medium. So what is refractive index? Refractive index is the ratio of sine of the angle of incident to the angle of refraction. This is known as a what? Refractive index. This comes from the Snell's law. From where it comes? From where it comes? It comes from the Snell's law, or we will also say that it comes from the laws of refraction. So there be the two laws, okay, as we have read out here. Okay. So next move towards the next move towards the sin I upon sin r is equal to constant, and that is the Snell's law. So as we have read that, what we have read that mu is equal to sin I upon sin r. This is what? Mu, and this is known as a what? Refractive index of a material or medium. Okay. So mu is what? Refractive index, and as according to the Snell's law, this will always remains constant. So refractive index of any material is their own property and always constant. For the different property, the value of refractive index for the different property will remain what? Different. Okay. So for the different property or different material, it will remain different. So suppose if a glass have the refractive index of the 3.1, water have the refractive index of 1.2, IL have the refractive index of 2.3. Okay. So these are what? These are the refractive index of various material. Different material have the different refractive index. Okay. And the refractive index never be changed. Okay. This remains constant. Okay. So now comes through a new phenomena of refraction through a glass prism. Anyone have doubt with respect to what? With respect to what we have read here? With respect to medium, with respect to medium. Medium means what? A space where light can travel. Okay. It is clear. So where light can travel anywhere. Okay na? In vacant, yes, light can travel in vacant. In solid, yes, light can travel in solid. In liquid, yes, light can travel in liquid. Okay. Opaque object, yes, light can travel through the opaque object. Okay na? So these are the same. In gaseous, yes, light can travel in air also. So, refraction through a glass slab, we will read here. Medium, there will be the two types of the medium, that is the rarer and denser, as we have read out. Okay, na? So, let us see when a light pass from a glass slab, what will happen and how it will show their property. Okay. So, just here it is what? Here it is saying that when light passes through a glass slab, from where? From where? From air. So, air become a rarer medium and glass slab become what? More denser than the rarer. As we know that solid is more denser than the liquid and liquid is more denser than the gaseous element. Okay. So, here when light passes through a glass slab, it will coming from the what? It will coming from rarer and passing through the denser medium. What will happen? So, beta you can also analyze from the from the condition of a crowd, from the condition of the speed of the vehicle here also. Na? So, here it is saying that when light passes through the glass slab, it will bend towards the normal. So, it bend not twice, here it will here it is wrong. So, it is not here twice, it should what? It is not working, sorry for that. It should what? Bend towards. Okay? Once at the entry and once at the exit. Okay? Next, this result in a, this is what? This will provide a lateral displacement of the light. This will provide us what? Lateral displacement. We will see there what is lateral displacement when we will read the ray diagram of this glass slab test. Okay. Next, the emergent ray is parallel to the what? Is always parallel to the incident ray. The emergent ray is parallel to the incident ray. Parallel means what? If suppose that this is a what? This is a condition of the glass. So, when it here incident ray follow, it will move towards the what? It is a normal. So, it will move towards the what? It will move towards the normal. Now, from here again it is passing through the what? The light is passing from denser to rarer. So, it will move away from the what? Normal. So, when you see these incident ray, after elongating it, we will see that incident ray and this is known as the what? Emergent ray. Emergent ray and incident ray is always what? This remains parallel. Okay. So, now and this distance, the distance between the what? Incident ray and emergent ray is known as what? Displacement. What type of displacement? Lateral displacement. Because why it is called lateral displacement? Because it is shifting what? Horizontally. It is shifting what? Horizontally. And when we wanted to talk about the horizontal, it is also known as the what? Lateral. Okay, it is also known as the what? Lateral. So, it shifts horizontally. So, this is called lateral displacement. Okay, na? So, shifted sideways and it becomes lateral displacement there. Next, let us see the diagram. So, the light bending, how this diagram show and where it is the, let us see where it goes. Okay. So, this is what? This is a refraction through a glass slab. Refraction through a glass slab. Okay. So, now I will use the yellow color. Okay. No, it is not good. I will use the green is good. Okay. So, clear all. This is a what? This is a refraction through glass. Okay. So, this is a glass. Suppose that this is a air. So, air is a what? Rarer medium. Rarer medium. When I will try to say rarer medium and denser medium, then the basic difference is what? It depends upon the refractive index of the medium. Refractive index, and it is denoted by what? Mu. Mu is what? Mu is the ratio of the angle of sin I upon sin R. Okay. So, basic difference between two medium is what? This depends upon the refractive index. That is mu of rarer is always less than mu of denser. This is the first condition for selecting a medium. Mu of rarer is always less than mu of denser. Okay. When we talk about the a speed of light in air, so a speed of light in vacuum, or sometimes it is also called a air, that is equal to what? 3 into 10 to the power 8 meter per second, and it is denoted by the C. It is denoted by what? C. Okay, na? So, and when, so this is a incident ray. This is a what? Its ray passes directly from here, but it is not a clear thing. It should move here, but it is not provided such like that. So, when a ray of light is coming from rarer medium, when it will goes in denser medium, it is what? It is moving towards the normal. It is moving towards the what? Normal. Okay, na? So, this is I, this is called R, and it is what? Angle of refraction, not reflection. It is what? Angle of refraction. Okay. Now, on depending upon the speed of light, depending upon the speed of light, refraction index is defined as, a refractive index is defined as what? A speed of light in medium first, that is C upon V. This is what? A speed of light in medium first, and V is what? A speed of light in medium second. So, medium second and medium first. So, the ratio of a speed of light in medium first with respect to the speed of light in medium second is also known as the refractive index of the material. Okay? So, this is also called a refractive index of the material. Here it is what? It is angle of incident. Here it is what? It is angle of refraction. As according to the case of the refraction, so refractive index is defined as angle of sin of I upon angle of sin of R. Refractive index is also defined as the speed of light in first medium with respect to the speed of light in second medium. Second medium. This is also a refractive index. Okay. Now, when we write mu with respect to 1 of 2, that means what? That means what? A ray of light coming from medium first and passing through medium second. Okay. When we wanted to write mu 2 of 1. That means what? A ray of light coming from the medium second and emerging through or passing through the medium first. Okay. So, this is the basic difference in the what? In the writing style of the mu, that is the refractive index here. Okay. So, it is clear. So, what is angle of refraction? This is the angle of refraction. Okay, na? Angle of refraction always lies in the medium second, okay, or where the refraction occur. Okay, where the refraction occur? When a light will change their medium, then the refraction occur. Okay, this is a angle of incident. This is a what? And this is a not a angle of incident. This is what? This is normal. This is normal. Okay, so let us move towards the clear diagram. Okay, na? So so that we can understand the topic clearly. Okay. Okay. So, now let us see the refraction through a glass slide. Refraction through a glass slab. Okay. So, suppose that this is our glass slab. This is our air. So, when we wanted to say it air, this is a rarer medium. This is a what? Denser medium. That means what? Let us say this is mu 1, this is mu 2. That means what? Mu 1 is always less than mu 2. Okay? Then there will be the two different medium as we have read out that. Okay, na? Now, suppose that a ray of light coming from a rarer medium. So, coming light, that is known as the what? Incident ray. Okay? Where the incident ray strike with the boundary of the medium second. Okay? At that point, the perpendicular distance or the perpendicular drawn is known as what? Normal to that incident ray. So, this is a normal to that incident ray. Okay? And the angle between normal and incident ray is known as what? Angle of incident, that is I. Now, when it will enter the medium second, due to the more density of the medium second, the light speed become decrease. Okay? So, you can also write that here the speed of light is c, and in here the speed of light is what? V. Okay? C is the more speed. So, c is greater than V. Okay? Now, so it will try to bend. It will try to bend. It will bending towards the what? It will bending towards the what? Towards the normal. Okay? So, now, because it is not going in the same path as the reflection occur. Okay? So that means what? It is not falling. The angle of incident must be equal to the angle of reflection. Okay, na? What? It is not falling. The angle of incident is equal to the angle of refraction. Why? Because it is not a reflection. In reflection, what we have read out? We have read out that angle of incident is always angle of equal to what? Angle of reflection. But here angle of incident is not equal to the angle of refraction. So, this is what? This is a refracted ray. What is refracted ray? The bending ray is known as the what? Refracted ray. So this ray is bending. Yes, this ray is bending towards the what? Normal. So it become what? Refractive ray. Okay, and this makes what? Angle of refraction. Now the ray of light try to emerge out from the glass. So it will emerge such like that. So the angle of emergent. Now at the emerging point, it will also make a normal. Okay, so one the another normal can be seen here. Let us say n, let us say n dash. Okay, so it is a also normal. Now this is a what? This is emergent ray. Emergent ray. Why? Because it is emerging from a glass slab. Okay. Now the angle between the normal and emergent ray is called as what? Angle of emergent. Is called as what? Angle of emergent. Now this is called the angle of. So there be the three type of the angle, as the angle of incident, as we have read about the angle of refraction, and as we have know about the angle of emergent. That is clear point. Okay. So now this is angle of emergent, angle of incident, and angle of refraction. Now when we try to elongate the angle, the ray of incident, so it will make such type of ray, and when we try to elongate the ray of emergent ray, this will make such type of things. Okay. So both the incident ray and emergent ray are what? From here we can see that the incident ray and emergent ray are parallel to one another. So first point, incident ray parallel to emergent ray. We can see this from here. Okay. Next, when this line will be parallel, when the two line will be parallel, then the what? Then the alternate exterior angle are always what? Equal. So from here we can also say that angle R is equal to what? Angle E. Okay. So from here, when the two lines are parallel, then their angle are always equal. Okay. This is from what? This is from where? This is from the property of the parallel line. Okay. So angle R must be equal to angle E. Clear? Now the distance between the what type of distance? The distance between the parallel lines. So what lines are parallel? That the incident ray and emergent ray are parallel. So the distance between the incident ray and emergent ray is known as what? Lateral displacement, and denoted by capital D. Denoted by what? Capital D. So if you wanted to measure the distance from point here to here, this distance is known as the what? Lateral displacement. And we know that the distance between the parallel line is always same at any point. Okay. That means what? If we wanted to measure here, this will remain D. If we wanted to measure here, this will also remain D. If we wanted to measure here, this will also remain what? D. So D is what? Lateral displacement. Okay. Lateral displacement, that means what? The distance between the incident ray and emergent ray. This is known as the what? Lateral displacement. That is clear? Okay now? So from here you can see that how when a light passes through the glass slab, how it behaves. Okay. So suppose that It is clear here, no, refractive index is clear. So, as we have read out that, so the refractive index of mu become what? Sin I upon sin r. It also becomes C upon V, where C is the speed of light in air or vacuum with respect to the speed of light in what? In any medium. Okay. Now, mu is also the ratio of the refractive index of first with refractive index of second. Okay. So, this is the also known as the index of first with respect to index of second. That is clear. Okay, na? So, now let us try the application of refractive index or refraction or what? Refraction, not refractive index. This is a application of refraction. Okay. So, suppose that this is a hose filled with water. Filled with what? Water. Suppose that here a 10 rupees coin is kept. Okay, 10 rupees coin doesn't have a Gandhiji, but I make it. Okay, Gandhiji. Where is the chashma? This is a Gandhiji. Okay, na? So, 10 rupees coin with a Gandhiji face is kept here. Okay, na? So, when we see in this glass filled with water, what we see that Gandhiji is seen Gandhiji is seen just upper from the surface or from the real position. Means the real position of the coin is here, but if we see from the other point, we will see that coin is lying here or here, such type of thing. Why it occur? Why it occur? Because the refraction of light. Okay. So, in a glass we can't see a coin at their fixed position. Why? Because of the refraction of light. Okay. The another example is what? Suppose that this is a pencil kept in that water. It looks bended. It looks bended. Why it looks bended? Due to the refraction of light. Why it looks bended? Due to the refraction of light. Okay. So, that is the condition, that is the application of refraction of light. Okay. Now, so let us see this type of things. So, let us suppose this is a pencil is in their original form. This is a pencil kept in the glass in their original form. But due to this refracted ray, we are not able to see this pencil as looking straight in this case. Okay. Why? Because this refracted ray is appearing like a what? Like a bending. So, due to the effect of their bending, what? This pencil image also become what? Bended. So, this pencil looks like what? Bended when we see from outside the glass. Okay. So, that is the main theme. Similarly, Similarly, if we wanted to see that for a coin, so it also making a some phenomena that if it will make the appearance here, so the image lies what? It appears like it appears like what? It appears like somehow arising from the surface. Arising from the surface. Okay. So, this is why this is also due to the refraction of light. Refraction of light. Okay. So, now let us we will do some question from the refraction of light, there with some numerical, and after that we are able to complete this topic. So, what is the question? Give me a 2 minutes. Yes. Here is my mobile. Okay. No. So, give me a minute. Okay, leave that where the generate quiz. Okay, that is a board all topic refraction of light, high school, remember, applies, evaluate, medium, MCQ 6, English, generate. Give me a minute. Okay, na? So, here we can see that there will be the various question, okay, as it is generated from the AIQ. That is the first question here is what is refraction of light. Okay. So, what is refraction of light? We know that bending of light. Okay. So, the answer will be what? Bending of, the answer will be what? Answer will be bending of light as it passes from one medium to another medium. That is clear? Bending of light as it passes from what? One medium to another medium. That is known as what? Refraction of light. Okay. Now, move towards the another thing. Where it gone? Next is what? Which of the following factors affect the degree of refraction of light? So, which of the following factor will affect the degree of refraction of light? That means what? Which of the factor affect the refractivity of any things? So, wavelength of light. Okay. Next is what? Angle of incident. Next is what? A speed of the light in the medium, or all of the above. So, we know that mu is what? We know that mu is what? Mu is sin I upon sin R. Sin R. That means what? It is depending upon I. Mu is directly proportional to the angle of incident. Okay. That means what? Mu is directly proportional to the angle of incident. So, if angle of incident increase, mu increase, and angle of incident decrease, that means what? Mu decrease. So, it will depend on angle of incident. That is the case. We also know that what? Mu is what? Mu is depending upon the speed of light with respect to the medium first and a medium second. Okay. So, mu is also directly proportional and inversely proportional to the speed of light. When we wanted to say that, or when I will try to say that mu is directly proportional to the c. That means what? If the speed of light in the medium first increase or if the speed of the light in the vacuum increase or decrease, then mu decrease. But we know that what C always remains what constant. That is equal to what 3 into 10 to the power 8 meter per second. But when we wanted to try the same concept in medium second, so mu is inversely proportional to the speed of light in medium second. That means what? If the speed of light increase in the medium second, mu will decrease, and if the speed of light decrease in the medium second, mu will what? Increase. Okay. So it will also what? Mu is also depending upon the speed of light. So there will be the two things, that what mu is depending in the speed of light, yes, angle of incident, yes. Now come towards the wavelength of light. So there be the different type of the ray. If we wanna to if we wanna to incident the X-ray, if we wanna to incident the ultraviolet rays, UV rays, that we know that UV rays. Okay, so different rays have the different wavelength, and we know that what the E is equal to what? H mu, or E is equal to what? Hc upon lambda. It is not from the class 10 topic, okay na, but I will try to I'll try to make it too simple so that you can understand it easily. So energy means what? A speed of light depends upon wavelength. We know that a speed of light depends upon what? Wavelength of light. Okay. So indirectly we can also say that refractive index is depending upon the speed of light, and the speed of light is depending upon the wavelength of light. So from here we can also say that what? That is the refraction depends upon the wavelength of the light. So all of the above become a answer of this question. So what? Question second, which of the following factors affects the degree of refraction? So that will wavelength of light, yes, angle of incident, yes, a speed of light in the medium, yes. All of the above should be the answer. Now the second case, the third. What is the phenomenon where the light bends when passing through a medium of different optical density? So when there be the change of medium, what will occur? There will refraction occur. So then answer will be what? Refraction of light. Answer will be what? Refraction of light. Okay. Now next question. Which of the following materials causes the most refraction of light? Most refraction of light, that means what? That means what? When we wanted to say the value of mu should be higher. The value of mu should be higher. So mu should be higher, C is constant, V should be what? Lower. Mu should be higher, that means what? C is constant, and we know that mu is equal to what? C upon V. That means what? V should be lower, so that we will get what? Mu as a higher. Okay. So which of the following materials causes the most refraction of the light? That means air, water, glass, diamond. So what should be the answer? The most refraction will occur from where? So diamond will occur the most refraction. Okay na? Where the speed of light will be the minimum, the refractive index is maximum. That means what? There will be the happening of the maximum refraction. Okay. If we wanted to say that the refractive index is higher, that means what? Refraction occurring there is higher. So the diamond will be the best answer for the refraction of light. Okay. Next. What is the angle of refraction? What is the angle of refraction, guys? What is the angle of refraction? Sir, the angle between the refracted ray and normal is known as what? Angle of refraction. So that is a clear thing. So the angle between the refracted ray and normal, B will be the correct answer. Okay. Next, see, which of the following is an example of refraction in everyday life? Everyday life, everybody life, okay na, university life, college life, hither life, thither life, my life, your life, and after that everything will be left with another wife. Okay, so what is here? Which of the following is an example? Okay, so what it will become? What it will become? Rainbow formation, seeing your reflection in a mirror. So seeing your reflection, that never be. Shadows being cast by object, picking up a pencil from a glass of water. So I have just taught it what example of the pencil. So the answer will be what? Picking up a pencil from a glass of water. Why? Because there will be the two types of the medium. One is what? Glass of water, and second is the what? Air. Okay. So D is the correct answer from here. Now we will solve some numerical on the similar topic, so that you guys are able to do some mathematical question from here. Okay. So let us give me 2 seconds. Okay. So where is the numerical? There will be not any numerical in this section. Okay. So let us see here a question. A ray of light coming from air passing through a glass slab having a refractive index (2.3). Okay, having a refractive index 2.3. Calculate the speed of light in glass slab. So here it is given what? Mu is equal to 2.3. We know that what we know that? We know that mu is equal to C upon V, where C is the speed of light in air by V is the speed of light in medium second. Okay. So as we know that C is equal to what? 3 into 10 to the power 8 meter per second. On putting the value, we will get mu is 2.3, that will equal to 3 into 10 to the power 8 meter per second upon V. That means what? After interchanging, we will got V is equal to 3 into 10 to the power 8 upon 2.3 meter per second. That means we will got 3 divided by 2.3, that will equal to 1.3 into 10 to the power 8 meter per second. So the speed of light in medium second will equal to what? 1.3 into 10 to the power 8 meter per second. Okay, that is clear from here. Now the next question is, right? Okay. So, IL has a refractive index of 1.5. Okay. IL has a refractive index of 1.5. A ray of light with a speed of 2.5 into 10 to the power 8 meter per second is passing from air. Is passing from what? Air. Calculate the speed of light in medium. So, similarly you can do this also question. Mu become what? That will equal to a speed of light. Mu is also what? A speed of light in medium first with respect to a speed of light in medium second. So, mu become what? Mu become 1.5. That will equal to what? A ray of light passing through 2.5 into 10 to the power 8 upon a speed of light in medium second. So, you will get a speed of light in medium second that will equal to 1.5 into 10 to the power 8 upon 2.5 into 10 to the power 8 upon 1.5. Point to point cancel, 5 5 ja, 5 3 ja. So, that become what? 5 by 3 into 10 to the power 8 meter per second. So, this will be the required speed of light in medium second. Okay. Now, let us move towards the another question. So, here it is given that the refractive index, the mu of glass and water with respect to air is 3 by 2 and 4 by 3. 4 by 3. Okay. If the speed of light, if the speed of light in glass is 2 into 10 to the power 8 meter per second, find the speed of light. Find the speed of lights in water. Okay. So, how we will solve this type of the question? So, from here it is given that refractive index of water with respect to air, suppose this is a refractive index of the first element, that is equal to what? 3 by 2. Next, refractive index of the second element, this is equal to what? 4 by 3. It is clear? Refractive index of first element is given there, refractive index of second element is also given there, that is the 4 by 3. Okay. Now, velocity of light in glass. So, velocity of light in glass. So, V1 that will equal to what? 2 into 10 to the power 8 meter per second. That is clear? Okay. So, after having all these things, you need to calculate the speed of light in medium second. So, what we know that? What we know that? We know that mu is equal to also n1 upon n2. We know that or not? So, we know that mu is also equal to n1 upon n2. That means what? The combined refractive index of the glass and water, that will what? Mu is equal to n1 upon n2. Okay. So, n1 upon n2, it will also give V2 upon V1. n1 upon n2 will give what? V2 upon V1. How it will come? It will come that when we wanted to try n1, that means what? A speed of light by V1, n2, that means what? A speed of light by V2. After dividing all these things, n1 upon n2, we will get C to C cancel, V2 here, so V2 upon V1. Okay, that is clear? How I have got that mu is equal to n1 upon n2 and that is equal to what? V2 upon V1. Not V1 upon V2, that will equal to V2 upon V1. How it will come? I will have showed you. Okay, I will have shown you how it will come. Okay, so mu is equal to n1 upon n2 and that will equal to what? V2 upon V1. So from there, therefore n1 upon n2, n1 upon n2, that will V2 upon V1. From here we will got V2 is equal to what? N1 into V1 upon N2. That will equal to what? That will equal to N1 is equal to what? 3 by 2 into V1 is equal to what? 2 into 10 to the power 8 upon N2 is equal to what? 4 by 3. So, 2 to 2 cancel and 3 it will goes here. So, that become 3. Now, 3 3 is 9 into 10 to the power 2 into 10 to the power 6, 10 to the power 8 can be written as this upon 4, 4 to the 25. So, that will become what? 25 into 9, that will equal to 225 into 10 to the power 6 meter per second. That is the required solution of this question. Okay. So, what will be the speed of light in medium second? Give me a minute. What will be the speed of light in medium second? So, V2 will equal to 225 into 10 to the power 6 meter per second, or it will equal to 2.25 into 10 to the power 8 meter per second. Okay. So, this is the required solution of the given question. So, now, everyone have got the concept of the refraction, the bending of the light, okay, how the light bends when coming from rarer to denser or denser to rarer medium, and the everyday life application of the refraction, and we have also done some numerical on this topic. Okay. So, that is all about the refraction of light. Okay. I will see you in the next class. Thank you very much. Okay.